Welcome to the second video of Chapter 6, which is Section 6.2, Use Proportions to Solve Geometry Problems. In today's video, you're going to be given proportions, which you're then going to use with geometric figures. This is the base for what we're going to be doing in Sections 3 and 4. In Sections 3 and 4, it's going to get a little more difficult. So let's jump right in by looking at example number 1. It says, in the figure below, AF over FE equals FC over ED. Find the length of ED. So in this example, we're already given the proportion. We know that this is a proportion because we have one ratio set equal to another ratio. So all we need to do is start substituting. Okay, so AF, well, on my figure, AF is 4. So this is 4 over FE, which is 6, equals FC, which is 22, over ED, which is X. And now this is exactly like last section, or the first section, where we use the cross products. 4 multiplied by x is 4x, and then 6 multiplied by 22 is 132. If I divide by 4, I get x equals 33. Remember that x was ED, so in this case, ED is 33 units long. Units, it could be inches, centimeters, feet, millimeters, etc. So that's part of what you're going to be doing in this section. That's the only example I have because I don't think that that's super difficult. All you have to do is substitute in the quantities that you are given. What this relates to is something called scale drawings. So a scale drawing is a drawing that is the same shape as the object it represents. The scale is the ratio that describes how the dimensions of the drawing are related to the dimensions of the object. So probably one of the most common examples of a scale drawing is a map. So a map represents the actual geographical state or country that it's really a drawing of. A map is just a smaller version of that geographic location. The scale in this case is like the key. So here on this first map, 1 inch represents 250 miles. So that's the ratio. The second one, 1 inch represents 20 miles. So 1 inch on the map is 20 miles in real life, let's say. So let's look down at example 2. It says the scale in the drawing below is 1 inch to 2,800 inches. So this is saying 1 inch on the map is 2,800 inches in real life. It says, how tall is the Eiffel Tower in inches? Okay, so this section's about proportions, so we're going to have to set up a proportion. So the scale is 1 over 2,800. The 1 is the map, or the drawing, and the 2,800 is in real life. Okay, so then we have this Eiffel Tower here. Looks like the Eiffel Tower is about 4.5 inches on the map. So it's about 4.5 inches on the map. We want to know how tall it is in real life. Again, we're going to have to use cross products. 1 multiplied by x is just x. And then I have 2,800 multiplied by 4.5. When I do that, I get the Eiffel Tower is about 12,600 inches. Just as a review, though, if you were probably talking about the Eiffel Tower in real life, I don't think you would be talking about it in inches. So if we divide by 12, we get the Eiffel Tower is 1,050 feet. Now, because this is a drawing, the height might not actually be 10,050 feet. It's probably going to be a little bit off of that. And in fact, the height is around 986 feet in real life. So we're a little bit off. We're off probably because the drawing is not 4.5 feet. It's probably a little more, a little less than that. Okay, let's move on to the next page. Okay, so example 3. It says you build a 3D scale model of the Reunion Tower in Dallas, Texas. The actual building is 560 feet tall. Your model is 10 inches tall. The diameter of the dome on your scale model is about 2.1 inches. Okay. So part A says, what is the scale used in this model? Okay, so the scale compares something on the model to that same part on the real tower itself. So here we are told the actual building is 560 feet tall. The model is 10 inches tall. It then talks about the diameter of the dome. Okay, that's extra information for us right now. We don't need that. The 560 feet tall and the 10 inches tall, those correspond. They're both in terms of height. So those go together. So the scale is going to be 560 feet. The tower itself corresponds to 10 inches on the model. I need to simplify this though. If I divide both by 10, I get 56 feet corresponds to 1 inch. So, sorry, that should be a 56. So 56 feet in real life represents 1 inch on the model. And then B says, what is the diameter of the actual dome? Well, we have 56 feet corresponds to 1 inch. Remember, this is in real life. This is on the model. That's equal to, pause the video and see if you can finish this on your own, please. Okay, so then we are told the diameter of the dome on the scale model is about 2.1 inches. So on the model, we have 2.1 inches. And then we want to know the actual dome. And now if I use cross product properties, I'm going to multiply 56 by 2.1, and I get 117.6. So the actual dome is 117.6 feet. And that's because we have inches in the denominator, so feet is going to go in the numerator. So hopefully you got that one right. If not, hopefully you know what mistake you made. If you have any questions, please make sure to bring them to class. We have 2 more examples. Example 4, I'm going to do with you, and then example 5, you're going to do on your own. So example 4 says the perimeter of a rectangle is 132 inches. The ratio of the width to the length is 5 to 6. Find the length of the rectangle. So first thing, I'm going to draw myself a rectangle. Okay, we are told the perimeter is 132. The ratio of the width to the length is 5 to 6. So think back to section 1. Section 1, we talked about a similar problem in terms of angles. I remember, I think the first example we did, the angles were 1 to 2 to 3. That didn't mean that they were 1 degrees, 2 degrees, and 3 degrees though. So in this case, the width and the length are not actually 5 and 6. They're 5x and 6x. 5x and 6x. I divided out some common number. So let's mark that on the figure. So the width is 5x, the length is 6x. Okay, so then it says find the length. Well, I'm going to have to start by finding x. I know that opposite sides in a rectangle are congruent, so I have 5x and 5x, 6x and 6x. Perimeter is found by adding up all the sides. So I'm going to add up all the sides. I have 5x and 5x, and then I have 6x, and I have 6x again, and the perimeter is 132. Now when I add all this up, I get 22x equals 132. Dividing by 22, I get x equals 6. And then I'm asked to find the length. Well, the length in this case is 6x. So my length is going to be 6 multiplied by 6, which is 36 inches. Okay, now let's see if you can do a similar problem. Looking at example 5. This time it says the area of a rectangle is 4,320 square inches. The ratio of the width to the length is 5 to 6. Find the length. So the problem looks extremely similar. The only difference is that this time we have area. So pause the video, try this one on your own. It's going to be similar to the last problem, but not exactly the same. Good luck. Okay, so I'm going to draw us a figure again. So we are told the area is 4,320. The width and the length is 5 to 6. So again, that's 5x and 6x. And I still know that my opposite sides are congruent. Okay, so now that area is what changes. Perimeter you find by adding up all the sides. That is not true of area. Area you find by multiplying the length times the width. So in this case, I'm going to have 5x multiplied by 6x. So that's length times width or base times height, and that's going to be 4,320. Got to be very careful simplifying on the left side. I know 5 multiplied by 6 is 30. X multiplied by x is x squared. Now I have to divide by 30. When I do that, I get x squared equals 144. Then I have to take the square root, and I get x equals 12. Again, I'm told to find the length. So in this case, my length is still 6x. It's 6 multiplied by 12, though, this time, which is 72 inches. So that one is certainly trickier than example 4, but hopefully we got it right. If not, hopefully we see what mistake we made. When you come to class tomorrow, we're going to be doing some examples similar to what was done in the video. Please bring any questions that you have. See you tomorrow.